Lami's theorem. First of all, we'll see the statement and the proof of the Lami's theorem, and then we'll solve examples. The statement is, if three coplanar forces acting at a point in equilibrium, then each force is proportional to the sine of angle between the other two. We'll just draw the forces like this. Here there are three forces, namely P, Q and R, and these forces are acting at a point O. The opposite angles to these forces are alpha, beta and gamma. That is, we'll write between Q and R the angle is alpha, between P and R the angle is beta, and between P and Q the angle is gamma. We will complete the parallelogram. The first side that we'll consider is OA, and that side will be equal to the force P. Then the second side we'll consider is OB, which will be equal to the force Q. Then we'll draw the other two sides and we'll complete our parallelogram. Here we'll give one point which we'll call it as C. Then let's just draw the diagonal, which is OC. As you can see, we are having the parallelogram OACB, and in this parallelogram we have two triangles. One is OAC and the other one is OBC. Here we'll be using one of the triangles, and we'll just write that parallelogram OACB, where OA and OB are the adjacent sides and OC is the diagonal. We'll use the sine rule, and as I said that there are two triangles, one is OAC and the other one is OBC. We'll be using sine rule for one triangle, which is OAC, and as per the sine rule for triangle OAC, it will be OA divided by sine of angle ACO. It will be equal to CA divided by the sine of angle COA, and that will be equal to OC divided by sine of angle OAC. Let's find all of these angles. Now here this total angle is 180 degree, and the angle between Q and R is alpha, so this angle will be 180 minus alpha. Same with this side also, the total angle is 180, so this angle will be 180 minus beta, because the angle between P and R is beta. Then here this angle will be 180 minus alpha, because it is vertically opposite angle. And then this angle will also be 180 minus beta, as it is vertically opposite angle. So we are having angle ACO, which is equal to 180 minus alpha. Then angle COA is equal to 180 minus beta. From these two angles, we'll have to find our third angle, which is angle OAC. Here we are having the two angles, so we'll just take it like this: 180 minus angle ACO minus angle COA, and this will be equal to 180 minus angle ACO is 180 minus alpha and angle COA is 180 minus beta. So this will be equal to 180 minus 180 plus alpha minus 180 plus beta. 180 will get cancelled. We'll be left with alpha plus beta minus 180 degree. And this whole angle is 360 degree. So we can write alpha plus beta plus gamma is equal to 360 degree, and alpha plus beta is equal to 360 minus gamma. Here we'll write it equal to 360 minus gamma minus 180 degree, and 360 minus 180, so it will be 180 equal to 180 minus gamma. Therefore we have got all our three angles. We'll just substitute OA upon sine 180 minus alpha is equal to CA upon sine 180 minus beta, and this is equal to OC upon sine 180 minus gamma, and sine 180 minus any angle, that is equal to sine of that angle, so it will be OA upon sine alpha is equal to CA upon sine beta is equal to OC upon sine gamma. And here our OC is equal to R. Same way OA is equal to P and CA is equal to Q. So we have got our Lami's theorem, which is P upon sine alpha is equal to Q by sine beta is equal to R upon sine gamma. Now let's just solve some examples. You'll have to remember this formula. In the first question, we have a sphere which is weighing 10 Newton and it is hanged as shown in the figure. We have to find the tension in the rope and the reaction of the wall. Now here the tension will be acting. Then in the downward direction, the weight, which is equal to 10 Newton. The wall will give a reaction, which will show it here, our wall. Now let's just draw the free body diagram. If you have not attended my lecture on free body diagram, then I'll suggest you to watch that video first. Now just draw a horizontal line and a vertical line, and we'll show the weight and the reactions. Here it is our wall. In the downward direction, weight is acting, which is 10 Newton, and the tension is acting at an angle. Here we'll write it as T, and this angle is 30 degree, and these are vertically opposite angles, so here also the angle will be 30 degree. As it is 90 degree, so here it will be 60 degree. Let's just apply the Lami's theorem. For T, the opposite angle will be the angle between our wall and 10. Therefore, it will be T divided by sine 90 degree, as the angle is 90 degree. It will be equal to, for R, the angle is between T and 10 Newton. It will be 90 degree plus 60 degree, which is 150 degree. So it will be R upon sine 150 degree. For 10 Newton, the opposite angle is 90 degree plus 30 degree, which is 120 degree. So it will be 10 divided by sine 120. We'll just write the values. T upon 1, R upon 0.5 is equal to 10 upon 0.866. Then we'll compare two values, which is T is equal to 10 upon 0.866. So we'll get T equal to 11.55 Newton, and R upon 0.5 will be equal to 10 upon 0.866. Therefore we'll get R equal to 5.77 Newton. So here we have got the reaction from wall, which is 5.77 Newton. You can write it as R wall everywhere. And we got tension, which is 11.55 Newton. Let's solve another example. Here there is a cylindrical roller which is weighing 1000 Newton and it's resting between two smooth surfaces which are inclined at an angle of 60 degree and 30 degree with the horizontal. Here it's already shown in the figure that this reaction is acting, which is RA. Then the other reaction is RB, and the weight is acting in the downward direction. We'll just show all of these three in our free body diagram. The angles are also given to us, which is 60 degree and 30 degree. Draw a horizontal and a vertical line. As given in the diagram, one surface is inclined at an angle of 60 degree and other surface is inclined at an angle of 30 degree, which means that in between this angle will be 30 degree and this will be 60 degree, And here RB is inclined at an angle of 60 degree and RA is inclined at an angle of 30 degree. As one surface is inclined at an angle of 60 degree and the other surface is inclined at an angle of 30 degree. Now we'll just write all of the forces. Here it will be RA, here it is RB, and weight is acting, which is 1000 Newton. Let's just write all of the angles. The angle between RA and RB is 90 degree, as this angle is 60 degree and this one is 30 degree. Then here we are already having the angle that RB is inclined at an angle of 60 degree, so we'll just write that. Then this angle that will be formed, that will be 90 degree. Then RA is inclined at an angle of 30 degree and this angle is 90 degree. Now let's just apply the Lami's theorem. RA divided by sine 150, because this total angle will be 90 plus 60, that is 150 degree. Then RB divided by sine 120 degree. As for RB, the opposite angle is 120 degree because 90 plus 30 is 120. And for 1000, it will be sine 90 degree because for it, this is the opposite angle and it is equal to 90 degree. RA upon 0.5 is equal to RB upon 0.866 is equal to 1000 divided by 1. Now we'll just compare this. RA upon 0.5 is equal to 1000. So it will be RA is equal to 1000 into 0.5, which is 500 Newton. And RB is equal to 0.866 into 1000, which will be equal to 866 Newton. Now let's solve another example. Here we are having a rectangular wheel which is 600 mm in diameter and its weight is 1000 Newton. It's resting against this rectangular obstacle which is 150 mm high. We have to find the force P. The weight which is acting in downward direction, it's equal to 1000 Newton. The other reaction that will be acting from this block on this wheel, which will represent it as R. Now we'll just draw our free body diagram. Here in the question, it is given to us that we have to find the least force, which is P, and for P to be minimum, it is necessary that it makes an angle of 90 degree with the reaction. So our theta will be equal to 90 degree. Suppose here the angle is theta 1. So here R will also make an angle of theta 1. This angle is 90 degree, as I have already explained. Then this weight is acting in the downward direction. We'll just extend this. We need this height. Here this much height given to us is 300 mm and height of the rectangular block is 150 mm. That means the left height will be 150 mm. So we'll just write this as sine theta 1 is equal to 150 divided by the radius of the wheel, which is 600 by 2, as the diameter is 600 mm. So the radius will be 300 mm. So sine theta 1 will be equal to 0.5 and theta 1 will be equal to sine inverse of 0.5, which is 30 degree. So we have got this reaction which is acting at an angle of 30 degree. We'll just represent that in our free body diagram. Here R is acting. Then the force P, we have to represent that in our free body diagram. Also this angle is theta 1 and here this will be the vertically opposite angle. So this angle will also be theta 1 and this total angle given to us is 90 degree. So this much angle that will be left, that will be equal to 60 degree, which is 90 minus 30. So we have got that angle which is 60 degree, which means that P will be acting at an angle of 60 degree with the horizontal. I'll just extend this backwards. Here it is 30 degree. Here this angle is also 30 degree. And this angle is 60 degree. Now between the vertical line and R, the angle will be 60 degree, and between the vertical line and P, the angle will be 30 degree. Which means between P and R, the total angle is 90 degree. Now for P, the opposite angle is this one, which is this much is 90 degree plus 30 degree. That is the total angle will be 90 plus 30. So we'll write it as P divided by sine of 120 degree is equal to R divided by sine of, here we'll find this total angle. This much is 90 degree and here it is 60 degree, which means 90 plus 60. So it will be R upon sine 150 degree. Then for 1000 Newton, this is the opposite angle which is equal to 90 degree. So it will be 1000 upon sine 90 degree. P upon sine 120 degree, will compare it with 1000 upon sine 90 degree, which is P is equal to 1000 into sine 120 degree is 0.866. So we'll get P is equal to 866 Newton, and R will be equal to R upon sine 150 is equal to 1000 upon 1. So it will be R is equal to 1000 into 0.5. R will be equal to 500 Newton. Let's see another example. An electric lamp in street is having 50 Newton weight suspended by two wires. These are the two wires having length 4 meter and 3 meter. The horizontal distance between the two fixed points are 5 meter, from which two wires were suspended. Find out the tension in both the wires. Here this is the triangle that is formed. For this triangle, firstly we'll find the angles theta 1 and theta 2. Here I'll just draw this triangle like this. ABC, this angle is theta 1 and this angle is theta 2. Now we'll just find the angles. Tan theta 1 will be equal to, let me just write the length of all of these sides, which is 5, this is 4 and this is 3. So tan theta 1 will be equal to opposite upon adjacent, which is 4 by 3. From this we'll find our theta 1. Tan theta 1 is equal to 1.333 and theta 1 will be equal to tan inverse of 1.333, which is 53.12 degree. Then tan theta 2 will be equal to 3 divided by 4, which is equal to 0.75, and theta 2 will be equal to tan inverse of 0.75, which is 36.86 degree. Now we are having the weight in downward direction. Here tension is acting. Here also tension is acting. We'll call this as T1 and this as T2. Let's just draw the free body diagram. Firstly, let me just show the angles here. This angle is vertically opposite angle. So here the angle will be theta 2. Same with this angle is vertically opposite angle. So this angle will be theta 1. We can just represent all of these things in our free body diagram. Here, this one is T1, this is T2, and this one is 50 Newton. Then let's just write the angles. Between this T1 and T2, the angle is 90 degree, which is given in the question. T2 is making an angle of 36.86 degree with the horizontal. this angle is 90 degree. T1 is making an angle of 53.12 degree with the horizontal. We'll just write that. For T1, the opposite angle is the one between 50 Newton and T2, which is 90 plus 36.86 degree. So it will be equal to 126.86 degree. T1 upon sine 126.86 degree. Then for T2, the opposite angle is between T1 and 50 Newton, which is 90 plus 53.12, which will be equal to 143.12 degree. And for 50 Newton, the opposite angle is that between T1 and T2, which is 90 degree. Then we'll just write the values. T1 upon 0.8 is equal to T2 upon 0.6 is equal to 50 upon 1, as sine 90 is 1. Now let's just compare this. T1 is equal to 50 into 0.8 and T2 is equal to 50 into 0.6. So we get T1 equal to 40 Newton and T2 equal to 30 Newton. Here we are having two smooth spheres which are of weight 100 Newton, radius 20 centimeter, in equilibrium in horizontal channel with the smooth sides having width 72 centimeter. We have to find the reactions at the contact surfaces A, B and C. First of all, we need to find this angle theta. For that, we'll find cos theta, which will be equal to Eg upon Ef. Firstly, we'll have to find these values, Eg and Ef, and sin theta will be equal to Fg upon Ef. We'll also need the value of Fg. Here we are having the total width and also the radius, which is 20 centimeter. The total width is 72 centimeter. From this we can find Fg. As you can see here, this total is 72 centimeter, this much is 20 centimeter and this much is 20 centimeter, which means Fg will be equal to 72 minus 20 minus 20, which is equal to 32 centimeter. Then Ef, which is this diagonal, this much is 20 centimeter as the radius is 20 centimeter and this much is also 20 centimeter, which means Ef will be equal to 20 plus 20, which is equal to 40 centimeter. Then we have Eg, which is equal to under root of Ef square minus Fg square, which will be equal to 40 square minus 32 square equal to 24 centimeter. Now we can just put all of these values here. This will be 24 upon 40, which is 0.6, and sin theta will be equal to 32 upon 40, which is equal to 0.8. Now we'll find the reactions that are acting on the sphere. Weight of 100 Newton is acting at point E. One reaction will act from the sphere, which we'll call it as Rd. Then from this side, one reaction will be acting, which is from the contact surface C. The reaction acting is Rc. We'll just show this in our free body diagram. Here we'll create Rd at some angle. We'll have to resolve Rd in two components, which is the horizontal and the vertical component. Here we'll just write this Rd. The angle between vertical and Rd is theta. Then we have Rc and we have 100 Newton, which is the weight. The reactions in the weight is acting at a point E. Let's just resolve Rd into components. This will be Rd cos theta and here it will be Rd sin theta. Firstly, we'll be writing the horizontal forces, which is sigma x is equal to 0. RD sin theta and RC are the horizontal forces. For this sign convention, I'm just drawing another diagram for your better understanding. Here we have RD sin theta in forward arrow, then RC is having backward arrow, which means RD sin theta will be positive and RC will be negative. So we'll have RD sin theta minus RC is equal to 0. Therefore RD sin theta is equal to RC. And RD into sin theta is equal to RC. Now we are already having the value of sin theta. But before that, we'll find sigma Fy, which is the vertical forces. Here as you can see, RD cos theta, and this is 100 Newton acting in the downward direction, which means RD cos theta minus 100 equal to 0. So it will be RD cos theta is equal to 100. Cos theta is 0.6. So we'll write RD into 0.6 is equal to 100. From this we get RD is equal to 100 upon 0.6, which will be 166.67 Newton. Now this we can place here. RD sin theta is equal to RC, and from this we'll get RC. RD is 166.67 into sin theta is 0.8, which is equal to RC. Therefore RC will be equal to 133.33 Newton. So we have got the reactions acting on one sphere. Now we'll find the reactions acting on the other sphere. 100 Newton is acting. From A, reaction will be acting, which is RA. From this sphere, the reaction will be acting, which is RD. And from the contact surface B, reaction will be acting, which will be RB. This will represent in our free body diagram. RA is acting horizontally and RD is acting at some angle. So we'll have to show RD as inclined. Here this is RD. Then this will be 100 Newton. This is RA, and here we are having RB. We'll resolve RD into components. This angle is theta. The adjacent side to theta will be RD cos theta. Here we'll write this as RD cos theta, and this will be RD sin theta. We'll resolve the forces. The horizontal forces, sigma Fx is equal to 0. I'll draw one more diagram for your understanding where I'll be showing the arrows. From this it is clear that RA is positive and RD sin theta is negative. Here we'll write it as RA minus RD sin theta is equal to 0. We already know the values of RD and sin theta. We'll just place that. Therefore RA will be equal to 166.67 into 0.8, which is equal to 133.33 Newton. Then sigma Fy will be equal to 0, and the vertical forces are RD cos theta and 100 Newton and RB. RD cos theta and 100 Newton are acting in the downward direction and RB is acting in the upward direction, which means RB will be positive and 100 Newton and RD cos theta will be negative. We'll just write it as RB minus RD cos theta minus 100 is equal to 0. RB will be equal to RD cos theta plus 100. RD is 166.67, cos theta is 0.6 plus 100. Therefore we get RB equal to 200 Newton. Let's solve the last example. Here we have to find this weight, for which we'll consider the equilibrium at point C. From C, the force will be acting, which will be FBC and FCD, and 100 kilonewton is acting in the downward direction. This will represent in our free body diagram. Here we are considering the equilibrium at the point C. Now this angle, we'll have to find it. These are vertically opposite angles. So this angle will also be 30 degree, which means FBC is acting at an angle of 30 degree with the horizontal. Then for FCD, the angle is already given to us in the diagram, which is 60 degree. So I'll just represent that at 60 degree. While you are drawing the free body diagram, you don't have to use protector, just draw it using a scale. Here this is FCD. This angle is 60 degree. Then this is FBC. Here 100 kilonewton is acting. This angle is 30 degree. We'll apply the Lami's theorem. For FCD, the opposite angle is this much. This angle is 90 degree and this is 30 degree, which is 90 plus 30, so it will be sine 120 degree. This will be equal to FBC upon sine. For FBC, this much will be the opposite angle. This angle is 90 degree and this angle is 60 degree, so it will be 90 plus 60, which is 150 degree. For 100 kilonewton, the opposite angle is between FCD and FBC, which will be equal to 90 degree. We'll just write this as 100 upon sine 90. FCD will be equal to 100 into sine 120, which is 0.866. So we get FCD is equal to 86.6 kilonewton and FBC is equal to 100 into sine 120, which is 0.5. So it will be 100 into 0.5, which is equal to 50 kilonewton. Now we'll consider the joint B. For joint B, weight is acting in the downward direction. One force will be acting here, which is FBC, and another force will be acting here, which is FAB. This will represent in our free body diagram. FAB will be acting at an angle of, here, this is the angle, and this are vertically opposite angles. So this angle will also be 45 degree, which means FAB will act at an angle of 45 degree with the horizontal. Then we are having FBC, which is acting at an angle of 30 degree as it is given to us in the question. Here this force is FAB. This force is FBC acting at an angle of 30 degree. Then we have this angle, which is 45 degree, and in the downward direction we have the weight. Let's just apply the Lami's theorem. W upon sine of opposite angle. Here the opposite angle will be this total angle, which is 45 plus 90 plus 30, which is equal to 165 degree. W upon sine 165 degree is equal to FAB. For FAB, the opposite angle is this one, which is 60 degree. FAB upon sine 60 degree. FBC is equal to 50 kilonewton. FBC upon sine of, this is the opposite angle, which is 90 plus 45. So it will be sine 135 degree. Therefore this will be W upon 0.258 equal to FAB upon 0.866 is equal to 50 upon 0.707. Therefore we get W upon 0.258 is equal to 50 upon 0.707, which will be equal to 18.25 kilonewton. And we'll also find FAB. FAB upon 0.866 is equal to 50 upon 0.707. Therefore we have FAB is equal to 50 upon 0.707 into 0.866, which is equal to 61.24 kilonewton. We have got our weight, which is equal to 18.25 kilonewton. This is how you can solve the examples based on the Lami's theorem. Thank you.